Ladies and gentlemen, we're going to do something unprecedented and new, and I don't know what it is. So we've asked I'm going to give you the microphone, Chief Scientific Officer, LBNL, to run a discussion session. Before you do this, your buses will be here at 5:30. Your bus will be here at 5:30.
New. It's called a quiz at the end of 3 days. So don't get shocked about the quiz. But I would like you to first take one of those blue index cards each. Of course, participation is completely voluntary. And I will explain to you what we're doing here. Just for using the brain power that has been assembled here and the fact that all of you now have been immersed for 3 days into thinking about quantum simulation, quantum computing in the future. And so I would like to ask you 4 very simple questions. 3 of those 4 questions have a single-digit answer. And what I will do is, you may know this wisdom of the crowd's approach by James Surowiecki. If you don't know yet, my simple example is, when you ask a farmer, how much does this ox weigh, they can make a guess, and maybe completely off. But if you get a crowd of 100 farmers together in a country fair and ask them and take the average hits the weight of the ox pretty exactly. And so I'm trying to do the same thing. And I will ask you 3 very simple questions and 1 not so simple question about the future of quantum devices, quantum computing. And all I would like you to do is write down the numbers. I will tally that, and then not too long in the future, give you the average. Now with this, I want to check that everybody has a card. Good. So just for sort of background information, that everybody starts with the same background information. The first transistor was built, of course there are debates on whether it was truly the first transistor, but the claim is now by Bell Labs, November or December 1947. The first microprocessor that was commercially available was Intel 4004. That processor had about 2,300 transistors, and that was released by Intel in 1971. So remember, 46, 71. The first 1 million transistor chip was the Intel 486, and that came out in 1989. So here you have 46, 71, 1989. So after I misled you with these initial questions, I ask a very simple question first, and this is, write down, that's question 1, write down which year do you expect quantum supremacy to be demonstrated. We heard on Monday it could be as early as this year, and some others think it's in the future, and maybe some people may think never. So infinity is an answer, or... Well, yeah, I know this is there's a lot of subtlety. I was shying away from actually defining it. If we can debate afterwards, after you wrote down your year, what it actually means. That's a good question to debate. So the second question I want to ask is, what year will we have a 1 million qubit system device? Right? No, just like an Intel 1 million transistor was a physical device that had 1 million transistors in it. So it doesn't have to be just one little chip, but some tangible, put the hands on 1 million qubit piece of hardware. We heard something on Monday. I heard something like 2027. Again, these subtleties. We are late in the day. Yeah, I know. It's an important question. Yeah, I know. That's... Well, let's say if you want me to use first universal quantum computer qubits. that's precise enough. Well, I implicitly assumed that just like on the Intel 4004, you could actually do something useful with it. Okay, so that was my second question. Now, my third question is also for your entertainment. So you probably remember two very famous mispredictions that have been often quoted about the digital computer age. So T.J. Watson, at that time the CEO of IBM in the 1940s, said, "I don't think there is a world market for more than 5 or 6 computers." And Ken Olsen, who was at that time CEO of Digital Equipment Corporation, which was very successful in the 70s mini computer manufacturer, said, "I don't see any reason for an individual to have a computer in their home." And so with those two statements in mind, I would like to ask you, when will you or your kids or your grandchildren own a quantum computer in your home? Answer, never, is also a possibility. So these were the three very simple numerical questions. I purposely, so everyone wants me to ask some more difficult question, but I said, let's first ask the easy questions. The answers are difficult, but the questions are easy. Did you think about it? The fourth question you can leave blank, but I wanted to stimulate now your imagination after I proposed the the quantum personal computer. So if you take the mid-70s to the early 80s, when the digital personal computers became developed, there were killer applications. In hindsight, the killer applications for the PCs were things like spreadsheets and word processing. I think that's pretty clear. So what's the application, the killer app for your personal quantum computer at home that will seduce you to spend a couple of $1,000s initially, or maybe only $200 in the long term, for buying such a thing at home? Just think about it. I will then collect those cards and pick a couple of at random, and then you can react to those random answers. But I will also average the years and tell you what the average is, and you can even get the full histogram and see what's coming out. And just to go back, just like the farmers who can estimate the weight of an oxen, you know the answer as a group. So I'm pretty sure about this. So if you want to do this, collect. Well, I wanted to ask, sorry, Travis gave a really nice talk, so I want to ask a bonus question for Travis and anybody else who feels inclined to answer it. And this is sort of because you touched on my pet project. When will be the first quantum computer on the top 500 list? Only for those who know what I'm talking about. This is just a real bonus question. Anyway, so if you have finished your cards, Irfan has volunteered to collect them. As I said, I will shuffle and read a couple of answers at random. I'm really curious about the killer apps. Jonathan, if you don't mind helping collect it. I was going to say it's not really a quiz. You could have discussed answers amongst yourself, of course. Okay, excellent. Okay, I like the very first one because it's probably the right killer app. I'm actually wondering if somebody actually writes down what I expect. as the killer app, but maybe not. Well, okay. Okay, well, the first one says Supremacy 2020, million qubit 27, home quantum PC 2100, application games, or drug development at the lab. And the last one was 2027, so this was the bonus question on the top 500 list. Let me see if I have somebody else. Okay, here we go. Here's one, says Quantum Supremacy 2018. I just picked some who said some interesting applications, which 1 million qubit device 2035, QC at home 2030, and then the application is secure ATM. So you will have a secure ATM system in your home, which probably dispenses securely bitcoins or something like this. So it's not an unlikely scenario. Quantum coins, yes, exactly, not bitcoins, exactly, qubit coins. Somebody pretty patent or trademark this while we come up with this. All right. Here is one, Quantum Supremacy 2017, 1 million qubits 2025, own my own QC at home 2045, application gaming. Okay. And will never make the top 500 list. Yeah, I think that's probably right. Thanks for top 500 list. Okay, here is one. 2020, 2050, 2120 for the personal computer, and artificial intelligence and machine learning. So you're a very serious crowd. Nobody has written down computer sex, because we know that's always the killer application. Okay, exotic virtual reality. Somebody has it about right. Photo search, analyzing history, VR games, Siri or alike. Okay, I think that's enough for this entertainment, so I hope I got you back in the neurons firing again. So Irfan also asked some of you for some serious questions that we might want to discuss in the next 20, 25 minutes or so. So let me start out with one that is sort of related to what we were just discussing with my little quiz here. And the question is, we may be able to demonstrate quantum supremacy with 49 qubits. Again, we heard about this on Monday. But this will be almost surely a stunt. What is the smallest, noisiest, weakest quantum computer that can achieve supremacy at a problem that somebody actually cares about? And then somebody actually cares about is defined, is willing to pay $1 million for that system. Million? Yeah, million is not. Yeah, they're paying already 10 million for D-Wave, so maybe I should make. Yeah. Well, I don't know who formulated the question. Maybe if the person who formulated the question wants to respond to this directly. It was just a lead into the question. The actual question is, once we have quantum supremacy, maybe I should phrase it this way, what is the first real serious task that somebody might want to run on a quantum computer that actually can make money or will have a scientific breakthrough, in a sense on what Jared said, suddenly figuring out how nitrogen fixation works and change world energy. Pardon? Oh, for nitrogen fixation, I would pay hundreds of millions of dollars if I were Dow or BASF. Any ideas? Yes, Dan? I'm not necessarily the expert on this. You can ask everybody here. This is supposed to be a conversation. Anybody can chime in here. I don't. Yes. People who don't care about computing, physics, who just interested in something. Okay. Yes. Yes. True. 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 Yep. That's a good one. We don't know. Optimize it. Okay, well, any other opinions or thoughts about this question? I want to just move on to another question, which is sort of in the same general space. And this is a question on, again, reflecting on the history of computing. If you take the emergence of the first digital computers in the early 1950s, it was still 20 years until you got, as I said, to the microprocessor-based technology. It was a big technology shift in itself. And then it took probably another decade to get to a real mass understanding of computers. So it's a long time. And we're in a different investment world in particular now. And the fact is that VCs are spending money only on apps that make short-term huge profits, but are not interested in investing anything that's long-term and anything that's hard technology. There are a few large companies like Google, like Microsoft, like IBM, who decided this is something important for the long term. But how is, if you want to use the term ecosystem, how is this ecosystem going to develop, or how should it be developed over the next decade to actually make progress to this? As long as, say, a few large investors, big companies today, are willing to spend their money, fine, and as long as we sort of can continue with a relatively small-scale research program, that's also fine. But I think there is something missing in terms of evolving this the same way the digital computer world evolved in the first 20 years and from the 50s to the 70s that I don't think is out there yet. So just wanted to think about what are the roles of universities, private companies, investors, the research labs. How can we make progress to build a larger community of quantum aficionados? Right. Public-private partnership, basically, which is, yeah. Do we need this? Are we all satisfied with the state of how things are today? And is that the same way we'd like to see things happen in 5 years, 22, halfway between now and the million qubit device? Yeah. A lot. I actually make this unfortunate quip that the killer app for early digital computers was nuclear weapons. Possibly. Maybe in some different but also national security realm. Possibly. Hartmut? Different point. Yep. 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 Yeah. Yes. Yes. That's good. Anybody can add to this? Sure. You mean 4 years? Or you forget the next 4 years? Well, not being very specific, but one of the government agency representatives who was here on Monday, at least, I had a very short conversation with him, and actually Hammond was in that conversation. He basically said, forget anything that the past administration has invested in, whether you can claim it's important for defense or whether you can claim it's important for national security, for competitiveness. Congress will, if there's an Obama administration tag on it, will wipe it away. That was specifically the conversation I had with somebody who is in the business of exascale, what is going to happen to exascale, and said, brace for cuts, it may disappear. Now, maybe people who are in Washington currently in the midst of a transition are much more negative than us who are 2,500 miles away, but still. Yes, tell us. Technology. Yeah. Yeah. Well, again, I like historical analogies. Bell Labs invested in transistors for switches, not for computers. Telephone switches. Okay, let me ask another question. Yeah. Okay. Maybe I'll ask one more question and then we do the statistical data. Since we're sort of in this speculation and some of us are in a bit more in a gloomier mood for whatever political reasons, here is a question. How significant is the risk of quantum computers turning out to be useless? That is, that even though we can build a quantum computer, it turns out that progress in classical algorithms and hardware prevents quantum computers from ever becoming cost-effective. For example, for many scientific computing problems, improvement in algorithms over the past 40 years have actually outpaced Moore's law. That was a question one of you posed. I have a very positive answer to that. I don't think that's true, but I don't want to buy not biased, of course, you guys. What would you think? Is there a possibility that's a big bust? Sort of like, will there be a quantum information systems winter, just like there was an AI winter because of overpromise or overhype? Pardon me? Okay. Yes. I don't. Okay, any more comments? Because Irfan has tallied the results, or actually, thank you for doing quick additions. Oh, yep, I know, it's kind of a 50-way parallel with combined operation at the end. Anyway, year to supremacy, average is 2020. Year to 1 million qubit, average is 2038. Home quantum PC, 11, so this is of course the question of average. 11 responses said never. The remaining average is 2053. Okay, there you have it. 2053, I have to really lose more weight to be around for that day. But thank you for giving me a worthwhile goal to continue with my New Year resolutions. Well, we're sort of at a good point. The buses will leave in, I think, sort of 5:20 or 5:25, or whenever we're ready. So there's still a few minutes left that you can debate the future, or yes. Yes, okay, so go ahead.